Ladies and gentlemen, on behalf of SC and NetApp, the sponsor of Theater 2, welcome to this session on applying data science techniques for cybersecurity operations, moderated by DISA's Chief Data Officer, Ms. Caroline Kuharski. NetApp is honored to sponsor this discussion. NetApp helps warfighters and DoD organizations discover all of their data from switch to VM to storage, regardless of vendor, and make sense of that data, identifying which data is most at risk. Caroline Kuharski is DISA's Chief Data Officer, where she identifies, prioritizes, and executes data and analytics and initiatives that are aligned to DISA's enterprise strategies and business outcomes. Previously, Ms. Kuharski was a strategic planner for DISA's Operations Center, leading to a 40% efficiency increase across business operations and a 15% spending reduction. Robert Landreth is the Technical Director for JFHQ-DODIN's Capabilities Directorates, driving automation and innovation. Previously, he led DISA's planning for AI/ML for cyber operations, as well as being branch chief for data analytics and lead engineer for DISA's big data platform. Dr. Philip Chan is the senior data scientist for DISA's CDO office, responsible for strategic data science programs and data management initiatives for DISA. Before joining the CDO last year, he worked at the Army Research Lab and U.S. Army Futures Command Data and Analysis Center, including work on AI/ML, C4ISR, and IoT. And Mr. Steve Fernandez is the data scientist in DISA's CDO, responsible for setting standards and overseeing implementation for data curation and analytics. Previously, he focused on AI back-end development for a health and human services data platform. Ms. Caroline Kuharski, the Chief Data Officer. Thank you.
Thank you. All right, good morning. Happy second day of AFCEA. Good to see everyone's smiling faces today. All right, well, it is my honor to speak with you today about the importance of applying data science techniques to enhance cybersecurity to support DISA's operational community. With the increasing dependence on technology, the risk of cyber attacks has grown tremendously. A core no-fail mission for DISA and JFHQ-DODIN is to ensure that our critical systems and networks are secure from our adversaries who seek to exploit vulnerabilities within our defense and in our infrastructure as a whole. This is where data science techniques can play a vital role to ensure the success not only of our operation communities, but of our national security here. Data science techniques involve using statistical and a variety of computer methods to analyze and interpret complex data sets. This approach can be applied to data security to identify patterns of behavior that indicate a cyber attack, detect anomalies of service performance, and track the movement of cyber threats. By applying data science techniques, the DoD can gain insights into the behavior of potential cyber adversaries, allowing us to take proactive measures to protect our networks and our systems. In the context of cybersecurity, predictive analytics can be used to identify potential attacks before they even happen. That's more being on offense instead of defense, where as a whole, that's where we should be going. By analyzing historical data from previous attacks, we can develop models that can predict when and where the next attack can likely occur. This can help us allocate resources and prioritize our defensive accordingly. Cyber defense measures that utilize data science practices such as user behavior analytics, threat analysis, and security information for event management are examples of what will win the game against those who wish to attack our infrastructure. One of the key benefits of data science is that it really allows us to identify patterns of behaviors that may not be apparent to traditional infrastructure monitoring methods. This is especially important in the context of cyber attacks, where adversaries are consistently and constantly changing their techniques and their tactics to evade detection. By analyzing large volumes of data from various sources, such as network traffic logs, system event logs, and user behavior logs, data science techniques can identify the patterns that will not only teach us how to be better on our defense, but also teach us how to go on the offense. And instead of us just creating honeypots and things of that nature, we can actually start using some of their attacks against them. This information can be used to take immediate action and mitigate the attacks and prevent further damage. Another benefit of data science is that it can detect anomalies in system performance. By analyzing system metrics such as CPU usage, memory, and network traffic, data science can detect unusual spikes in activity, which will indicate when there's a malicious activity happening. These anomalies can then be investigated further to determine the source of the attack and take that appropriate action. In order to successfully apply data science techniques within DISA, we are prioritizing the following. Data quality. High quality of data is essential to accurate analysis. If you're only going to analyze garbage, you're going to get garbage results. An area of focus of mine is to enable the collection of data in a consistent and structured manner and make sure that it is clean and defined to meet the DoD and JFHQ-DODIN needs. Leveraging DISA metadata framework, or the DISA metadata framework at the data source layer, will influence and enable data maturity and consistency across the board. Data expertise. Data science is a highly specified field. A lot of people are doing great things in this arena, and we want to get those great people here within DISA. But we would be doing a disservice to our mission if we did not invest in those expertise that are not only in-house or available through partnerships with private and public mission partners. We in DISA are focusing on establishing more data scientist roles and other data-focused opportunities such as the data officers, data stewards, and various data-focused automation and optimization opportunities throughout the agency, but also robust infrastructure offerings. Data science requires significant computing power and storage capacity. So DISA and the DoD must ensure that we have the necessary infrastructure in place to support these techniques. So with the offerings such as Joint Warfighter Cloud Computing, Cloud Capability, JWCC, DoD is able to leverage a variety of infrastructure services and cloud-native advanced analytic capabilities to support the users from headquarters to the tactical edge. So data science techniques have a potential to revolutionize data cybersecurity for the DoD. And by leveraging the power of big data and cutting-edge methodologies, we can proactively identify and mitigate potential threats and keeping our nation's critical infrastructure safe and secure. Okay, so now that I said my spiel, we'll go ahead and go into some questions. All right, Mr. Bob Landreth, I'll go ahead and start with you, sir.
Ms. Caroline, would you mind throwing up my slide?
Oh, nah, no slides for you, Bob.
I need a special slide.
Oh, here we go.
All right.
So, Bob, first question to you is, how does JFHQ-DODIN currently leverage data to manage cyber risks across the DODIN?
So the first thing I wanted to do is explain Joint Force Headquarters and our responsibility and area that we have to deal with, which is the DoD, also known as the DODIN. The DODIN has been chopped up into 45 areas of operation, which is the services, components, and agencies. So that's what you see sort of around the outer edge there, is each of those environments that we're overall responsible for the cyber risk of those particular environments. Now, we have a supporting and a supported role with this. The agencies, the COCOMs, et cetera, are responsible for their environments. But DODIN oversees everything and tries to help in a supporting role as much as possible. The other piece that you see on the puzzle over there is different areas that now our IT terrain has expanded into. You've got things like mobile, you've got cloud, you've got all three networks, you've got NIPR, CIPR, JWICs. All those environments fall under our area of responsibility to make sure that we manage cyber risk supported by, cyber risk for the mission supported by the DODIN. And that's kind of the summary of one of our mission areas that we get after. Mm-hmm. Now, when General Skinner wakes up in the morning and he wants to come down, and he's got 5 key questions he's going to ask us. What are the biggest threats to the DODIN? What systems do we have out there that are vulnerable to those particular threats? Who owns those systems? What mitigations do we have in place for those systems? And finally, the biggest thing is who's responsible for those systems from those areas of operation. And so really, in summary, what we're getting after is that we're managing the risk by utilizing the data from each of those environments, in those IT environments, to aggregate everything together to identify and answer those 5 key questions.
Oh, good one. So it sounds like, a lot of the conversation yesterday in the keynote, at the lunch keynote, was talking about setting the globe. And I think that's exactly what we're doing by encompassing, and working with that whole operation framework of individuals. So Phil, question to you, sir. What are the robust data science technologies and techniques to fight against these top 10 cyber attacks and their impact to organizations? And let me get to your slide. There you go.
Okay, let me get into it one by one. There are 10 cyber attacks, right, on the horizon and have been living with us for quite some time. So what kind of impact will that be on the organization, right? So in terms of the first one for the phishing, right, basically you need to do a regular defense by backing up the critical data, right, in order to prevent that happen. Training employees to identify like phishing emails, maybe even conduct regular simulations that prevent those phishing attacks. That's number one. Number two is for ransomware. Ransomware, if you take a look at that graph there, it's also extremely, I would say, frequent in within this couple of years of business. You can see the news. Things are being hacked into Baltimore City. The whole thing was locked down because of ransomware. Hacker demanding large amount of money because all the data was encrypted. It's really a mess. So what should we do? Well, regular backup critical data, that's important. Have another site or another area, implementing some sort of multi-factor authentication, ensure all the software is up to date all the time. Right? But which kind of difficult sometimes, but if that's the case, then you need to have somebody tasked to do the check all the time, 24/7, or maybe a robot, software robot of some kind, to do those checking and updating of the security patches and help mitigate those impact of the ransomware attack. The third one is a malware. Malware means you install a lot of things into the system you don't know of, and that could be a problem, and has been a problem, even on a cell phone or some other devices, remote devices. So you have to be, virgin or really focus on how to update those latest patches, and also the firewall itself has to be configured in such a way that it's like smart enough to get all the information, latest information. That could be achieved by machine learning, and some of the things that you can inject into that layer inside the firewall. The fourth one is the DDoS attack. Those attacks are critical because it's really a more like certain level attack that go into the cloud level and also the web firewall level. So we need to have a defense mechanism, and actually there's software out there to prevent those DDoS attacks, at least in some preliminary level. Although you cannot resolve an entire issue, it's still there. DDoS is still there because they're remote sometimes. They're hidden somewhere, and they are probably across the net. The other one is the APT. APTs are called as advanced persistent threats, which is the other way to actually defend that is by using so-called multi-layer sort of security controls, like intrusion detections, installations, and preventing the system, the network segmentation, right? And for better access control. That will help that to solve the APT. The other common attack is including a SQL injection, but that's pretty much on the database side. When you do a query, that particular injection will basically sneak into the website to the server side, in injecting vulnerable SQL arguments into the database and extract false information. So that could be resolved by installing some sort of a filter and web app and on top of that layer, and be able to constantly scan and through the firewall and to prevent the SQL injection at the attacks. Lastly, I don't want to go into everything, but the zero-day exploit, which is kind of common, that if you don't have all the hole being patched and not up to date, hackers can easily find a hole and find a way to get into it. And really, 0 day means the day one. There's no day one. It's just happened because they find a way to get in there. So that's incredibly dangerous. We envision maybe machine learning, some sort of simulation or modeling to help a 0 day exploit, to reduce the risk, and using a threat intelligence feed from some other sources, to help. And machine learning is most likely part of it. And with data science, of course, training that. And data science, you can aggregate a lot of data through different data catalog, maybe around the world on the network, and learn and fed into the model, machine learning, to be able to do the leg up, probably the self-training, self-simulation to detect most likely the 0 day attack. Man in the middle is kind of as well another type of attack for socket layer, SSL and TLS layer attack. That could be mitigated by strong encryption, right? I mean, there's a different layer of encryptions. If you are, cybersecurity certified, you know that you need to pass through the certain tests, right? I mean, most likely we'll ask you what kind of encryption would that be? Is it strong enough? What kind of level? So encryption definitely will help, right, on that level. And the lastly is the social engineering. That means be careful, people are sort of serving you and doing things that not supposed to, asking you passwords for no reason, or try to impersonate, right? So just be careful on that part. And also the last one is actually insider threat that you worry about, that's access control for ex-employee or current employee, or certain things that could happen for some reason. But anyway, that's pretty much I cover. Thank you.
Excellent. No, thanks. When it comes to cybersecurity and the threats that we have to deal with every day with these, we were showcasing the top 10, but really whenever we look into it, there is a plethora of cybersecurity threats that, we deal with daily against, JFHQ and really within the DoD as a whole. So ensuring that we are implementing methods to see these attacks, mitigate these attacks is extremely, extremely important. So we're going to go ahead and go into what a cybersecurity data science process looks like. So Steve, how do data science technologies such as machine learning, AI, and data analytics, how can those be used for the cybersecurity operations?
Thanks, Caroline. Do you want to go ahead and put the slide up on the screen?
I do, but it's not letting me, so let's use the clicker.
Thank you.
All right.
So what you see here, it's titled Data Science Process Pipeline, right? Notice it's not data pipeline, it's not machine learning pipeline, it's a data science process pipeline. So at the core, right, the key behind data science obviously is the data, right? So sourcing data from a reliable source, a verified, trusted source, and from there, you're handling that data in accordance to what the use case is. Is it analytics? Are you preparing that data for a machine learning model? Is this used for a visualization? Because what a machine learning model likes, for example, it's not these absolute figures that decision makers like. You can't show a decision maker in a visualization just variables scaled from 0 to 1. They'll probably scratch their heads and it won't help them make decisions. But on the other hand, you're processing data differently to accommodate the needs or the need for model performance. So that's the first thing, right? It's sourcing the data from the right place and then taking steps to pre-process that data according to the use case. So generally speaking, that can be rules-based, that can be automated, and if it's done correctly, you have logic that can apply at a larger level. Again, use case specific, but you're not going in ideally and tweaking that process, manually or even programmatically. It's completely automated. So that's the first part, right? Is preparing that data and sourcing that data. And EDA, this is something that a data scientist or whatever the title is they're taking that data and they are trying to glean insights, what features, what variables are the most important, right? So this is where you might want to tie in, in this case, a cyber expert or a cyber analyst. They have domain knowledge to say, hey, we think these features are the most important. These are what we look at, qualitatively. But if you start running algorithms, these algorithms might detect or determine that there are variables out there that you may have thought, hey, these don't really seem to be that important, but in reality, they do have feature importance. So exploratory data analysis is pretty big, and you'll uncover some key aspects of the data by doing that. So at this point, you have that data, you sourced it, you cleaned it, you pre-processed it, normalized it. So you're taking some of that data and you're saying, okay, we're reporting threats, we are visualizing with that data, and then that other subset of data might be fed into a machine learning model, right? So there's a couple different ways that machine learning models might be utilized. The best case scenario, obviously, is we know that this is a threat or this is not a threat. But in the real world, we don't have worker bees or anybody for that matter that can filter through data manually or even programmatically and identify these threats as being a threat or not, or high risk or low risk. So that's a need, right? That's a big need, is being able to label this data, and that's a form of tagging. But in this case, it's very granular, labeling this data, and if that can be facilitated in a rapid manner, we can shift resources to more critical and important things. So the best case scenario, right, is we have those labels. Now you can say, okay, we're going to train a model based on these observations, this data corresponding to a threat or not, right? So again, that's the best case scenario. But in the real world, we have unsupervised learning. So basically taking the features of data that we may not know to be a threat or not, and putting that into a feature space and seeing, okay, these align together, these are clustered together. And that can be really helpful in identifying, malware samples, network traffic patterns, and even it can kind of solve the problem where you're developing pseudo labels for that previously unlabeled data, and you can use that to train another, a model, with the caveat that you have to pretty much tag metadata there that this was generated by AI, right? So that's, at a nutshell, those are some options available to bolster cybersecurity operations. The goal here is to automate as much of this as possible, right? And we'll get into that in the next slide. But at a high level, this is a process pipeline that we would seek to follow.
So Steve, I want to jump in on this one, right? Because you saw the picture earlier, the DODIN, right? And I've got 45 areas that I've got to get after. Each one of those 45 areas has their own IT architecture, their own cyber sensors, their own systems, et cetera. And we need data scientists to be able to go in and answer those 5 questions that I asked. And it's going to be found at different spots everywhere you look. So think about the complexity and the intensity of a data scientist that's got to deal with all the DoD to provide summary information or risk models for the DODIN. So I just wanted to sort of highlight that complexity and how it all ties back to the work that you're doing.
Yeah, the process pipeline, you can use that in a variety of environments, but Bob, that was a really great point that, while we have those 45 different domains, the foundation of what we're doing might be the same, but it's going to be very different, very complex data all across the DoD, where you may say boat, he says ship, you say vessel, but in the end, data is going to be data, and you're going to have to just mitigate it within that pipeline. So Steve, another question for you. If I can go to the right slide. Yes. How does data analytics using the data science, how can that be used to identify patterns and anomalies in cyber data? Kind of talking back to that pipeline that you were referring to, but how can we see it within the analytics of cybersecurity as a whole?
Sure. So spoke a little bit about unsupervised learning in case where you don't have labels, right? So clustering, we can cluster, potentially anomalies, right? You can always implement rules-based logic based on, domain knowledge. We know that this would potentially be an anomaly. You can base it on a distribution of data and use statistical methods to determine, this is potentially anomalous and this isn't, right? As far as analytics in general, right, one big thing could be time series analysis. Being able to group data based on a given feature or collection of features and analyze how that changes over time, like an evolution. This is pretty common in other domains as well, but this allows you to, say, group by a given region and see how threats evolve within that region, for that matter. But at a high level, right? Data analytics can mean a lot of different things. So it really depends on the use case, and visualization is really a main use case because it puts insights into the hands of decision makers very quickly, and that is critical as threats evolve.
Yeah. At least I know for me, anytime that we start briefing, you don't want to just have a bunch of words on the slides, pictures, like you were saying, those visualization agents, that is what's going to help leadership and just, people as a whole to really see what they're trying to make a decision on.
Yeah, just to jump in there, I really can't overemphasize the data tagging aspect to it. I know that historically, we built big data platforms and we'd attempted to standardize stuff and we attempted to add data tags to it. One of the things we found was that we over-normalized the data. And so we said, an IP address is an IP address, right? By the time it hit the analyst community, they got back to us and said, no, we have to understand the context around this particular alert. Which direction was it going? From the internet? Was it going inside out? Where was it in the network, et cetera? So there was a lot of contextual stuff that we missed by over-normalizing. So it's a careful strategy that we've got to get after when we're doing the normalization and the tagging. You got to get the right tags. The other thing that we were always cautious about was not over-tagging the data. If you over-tag the data, you're going to inflate it, right? So what I originally had, this 1 petabyte system, all become a 3 petabyte system just because of the augmentation that I added to that data. So just a couple of lessons learned that we've done in the big data community over time.
No, good point. I mean, we want to know more about the data within the set, so we want to tag it, but like you were saying, the more we tag it or normalize it can really bog it down and make it not as useful as it should be in the end. Awesome. Okay. All right. So Bob, we've been talking about using AI, ML, well, just data analytics for cybersecurity and really defining those roles. So how is JFHQ-DODIN looking to see benefits, or are you seeing benefits of these capabilities pertaining to cybersecurity in your environment?
So one of the big parts of what Joint Force Headquarters does is we've got an intel cell, we've got an organization that does a lot of the intel analysis up front, right? We're going with the intel drives operations concept. And so as we're providing intel comes in a lot of different formats. It can come in sticks format where it's structured, but a majority of it is unstructured. And so having an analyst sit down and read 700 pages of a PDF document of an analysis that's going on in the world really doesn't make a lot of sense. And so one area that I want to see a lot of drive, we've started getting into it, is using natural language processing to look across those 700 pages of documents and look for data that can sort of give us a better picture and a correlation in an automated fashion rather than having the analysts walk through it. Additionally, we've done some work where one of the other problems that analysts have to deal with is the fact that they get 1 million alerts a day. And taking those alerts and either validating them or verifying them using AI machine learning against other data sets is a key area that we're definitely driving towards. I guess one of the other areas is we're seeing a lot of industry building in the AI ML, right? So I don't know what's under the covers, but a lot of the focus area has been driving at the endpoint level, where they're doing analysis and coming back and once again setting the priority for those particular threats and where we want to get after, as well as we're seeing this in the boundary areas. So we've got, the DISA boundaries got stood up. Adding AI ML to that also has been augmenting where we prioritize our threats, or where we see the threats coming in the biggest area. I think that's everything.
Yeah, no,
Yeah.
yeah, I think you covered it. Yeah, and also by able to see that, do you feel that that's really kind of helping you to prioritize your resources accordingly?
Yeah, definitely. It's, one of the things that everybody loves in DoD from those 45 areas of operations is that DODIN does a thing called task order. So we're out there and we're building up these threat models and we're determining what's the right priority stuff, right? And so then we've heard the term, we're hitting with the bazooka of task orders. We're just going, patch this, patch this, patch this, patch this. So for us to come back and say, I realize that there's 10 things we got to get after, but these first 2 are really important, helping to prioritize it for those DAOs, I think is really helping set the priority for those guys and what they need to get after. Another piece to the puzzle on the growth area that we're getting after is the concept of SOAR or playbooks. So not a lot of the analysts in DoD trust the SOAR and playbooks at this point in time, right? It's go ahead and let your little machine do its thing and then come back with me with a suggestion as to what I want to do with this particular action. So I see as the things mature and folks start trusting the AI machine output, a lot of those playbooks are going to become much more automated. And so that's definitely a direction that we're headed in.
Yeah, I think that's really what's going to be vital for the evolution of not only utilizing data analytics, becoming more data centric, but for us to be able to evolve with our threat taking measures. So great, thank you. So wrap up question. So I'm going to say the question and each of you just kind of give me your input, and Steve will start with you and then just kind of head this way. So where do you all see opportunities for data science technologies to enhance operations based off the threat definitions, data science technologies, and the benefits of those?
So going back to what I said, right? Being able to make decisions rapidly. So we want to take these processes, kind of like I described, and crunch the time it takes to complete them on a cycle. So reducing the time from a detection and a response, right? So that requires automation. You see here, benefits of automating artificial intelligence in cybersecurity. Using these tools, right, you can take data and report, flag quickly and respond with a response. Also, using technology versus human resources, it's going to reduce error. Rob mentioned, there may not be trust in an AI output, but from experience, and I think a lot of developers can tell you, mistakes are made when you don't automate, frankly. And we're going to free up resources for more complex tasks by using AI, machine learning, and really, the idea is to evolve faster than the adversary. So we need to use these data science tools, techniques, in order to accomplish that.
No, good point. Because, like you said, staying ahead of the adversaries, because they're already using it today. So we need to use it ourselves and then get more advanced than they are. So Phil, same question to you. Where do you see the opportunities of data science
Right.
and the benefits in cybersecurity operations?
I can see a lot of benefit, really not just the theoretical, but actually practical. And I can see a lot of business coming out of this, including the DISA operations to enhance the detections, really with the good algorithm that you can develop in a lab, or maybe even a practical sense on a daily basis. We can definitely add that, and also the incident response. Again, a lot of things that actually on the fly, right? Something happened, so you need to put out the fire. So the incident response that's second important. To reduce the response time and minimize the problems, security problems, and also the improve that input the information to inject into our database. That this is what happening out there, the situation awareness, that feeding the pattern, what's out there, and really 24/7 support. And lastly, I think it's really the predictive modeling. I can see another big plus to be able to prioritize the security threats and efforts where we need to allocate resources, right? On that sense, overall, I think decision making, right? I mean, a person like Bob's positions, really do that sense. He needs a dashboard. He needs something, right, to really give him a decision making, and on a human scale, not just the machine scale. So all those integrate him in a loop with the decision making on the fly with a machine learning, helping it. It's like an assistant, really a smart assistant to help him judge. Not just a Bob, maybe even pass on to a executive, or maybe even down to operator level, be able to see, this 1, 2, 3. We have hitting that level. We need to make a decision, and that's what we come up with. The last thing I think is really the so-called monitoring and continual monitoring in such a way that you really have that opportunity with the data science adding to the machine learning. You have a continual, really substantial support in that sense. Other than that, I think the security-wise, you have sort of adaptive security. In other words, I beef up my security because of the fact that I learn what's going on already. So I beef up strategy, automatic strategy 1, 2, 3. And that's the moving strategy, which is great. That's I can see what's going to happen down the road.
All right, Bob?
Caroline, how much time do we have left? I'm about to get going.
All the time. All the time in the world for you, Bob.
All right. A couple of soapboxes to get on. So I'll start off with some of the opportunities for the AI machine learning. I talked about the threat intel, et cetera, using natural language processing to comb through that data. That's an important area for us to focus on. Another area that Steve talked about was the data augmentation stuff. And so where I see some of the challenges is I've got a flow of sensor data coming in at me, and I need to add a lot of augmentation data to it. I want to know where did it come from and where's it going to. I want to understand more about it. Is this IP address or this domain on a blacklist, et cetera. So building that into the technologies, I think is going to be really important as the sensors output to include all that so that my artificial intelligence models at the SIM or wherever they're being implemented can actually use those attributes. All right, now for the soapbox piece. So one of the challenges we've got with machine learning, artificial intelligence, is that the learning data piece of it is a challenge area. And what I mean by that is we've got lots of cyber alerts, we've got lots of cyber sensor data coming out of it. But nobody knows which of those alerts is a good guy or a bad guy. There's a ton of false positives that we've got to get through on any given day. And where I see opportunities for us is to drag the human back into the loop of this analysis. And so wherever this alert may be firing, et cetera, a typical analyst will then go, okay, well, let me check this thing out, and they'll go over and they'll do analysis against packet capture or wherever else to say, yep, this was definitely a bad guy. What I need is the ability for the analyst to then go back into the system that set the alert and go, confirmed, this is a bad guy, or this is a good guy, this is a false positive, et cetera. And so thinking about that concept and putting that back into our technologies, I think is an important way forward. And I know it sounds strange, but it's for building that learning data in the first place and in ensuring that drift and things don't occur in the future, right? Because just this model's only good for a couple of months before somebody changes it out. And so no matter which way we look at it, the analyst is going to be in the loop, and they have to be in the loop. And I know that a lot of the executives, et cetera, think, I've got this magic fairy dust and I can just put it out there and everything's going to be taken care of. But as I see it, it's my personal opinion, the analyst has got to stay in the loop on this in the future. And so providing that feedback within the systems will help. What that's going to build towards is self-learning artificial intelligence. And so I don't want to have a bunch of developers having to constantly go back and redo the models, et cetera. I would like for the system to be able to analyze that input from the analyst and say, okay, I see the other attributes that represented this thing as a bad guy. Let me go ahead and start modifying the models automatically. And probably the last area that I would get into is supply chain risk management. So we've got methodologies for doing supply chain risk management today, which is primarily looking at vendors and all their friends and who they talk with, et cetera. And so getting that more automated to better understand the relationship between companies, et cetera, but then get down into the product level itself and understanding the actions that those products are taking. So it could be software analysis of the output that those systems are doing. It could be things embedded inside the hardware, strange chipsets, et cetera. But definitely focus on the supply chain risk management areas for the future of data science, et cetera.
It's a great point, like you were saying, understanding what are the after effects for what we're putting out there. Like, so we can see the data and the analytics of that. But whenever we do start implementing and putting more things on the network, that supply chain risk management is a key portion of focus. So thank you for that. Mm-hmm. Okay, so that is our brief for today. We're available for questions. There's a microphone. If anybody has any questions for us, you're more than welcome to get up there and ask them now.
You can put up a little slide with our 4 pictures on it.
The what?
There's a slide with our 4 pictures on it. You can put up
Those
there.
pictures?
It's cool. You didn't use it yet.
Excellent.
Hi.
Sir.
Go ahead.
Good morning. Todd Martin with AT&T. What can
Hi.
industry do to help support some of these efforts in harvesting your data, normalizing it, and making it democratized across all of these different disparate systems and users and communities that you have to serve?
Well, I definitely talked about, the fact of putting the human feedback loop into those end products for the alertings, et cetera, to allow those machine learning models to get after. Building out on the supply chain risk management. A lot of the things that I talked about would be, I think, good focus areas for industry to get after. Phil?
Definitely, I certainly agree with that. As a matter of fact, pay attention to the so-called data aggregation, data catalog, data science part, because that's going to grow. Something called data fabric. That means, in other words, you have things that all link together as a fabric. Guess what? The machine learning is ingrained into the fabric, can learn and merge some of the data pieces into some sort of a fabric. I mean, theoretically, right? But actually, they all talk together, talk in such a way that through the ML AI model, they can start exchanging information, start learning. That's incredible. That's it's growing, and I can see one day it will going to happen. And it's around slightly happening right now. By for example, the Chat GPT, some of the machine learning, a model out there, right? You have more powerful ones suitable for our use, for DoD use, which is kind of in-house, and you can start building that fabric, data fabric, and that will apply to cyber, to many, many applications. That's the fundamental part. Data is the strategy, it's the asset, it's the fabric. Machine learning is part of the vein, the electricity that inside it, and then transmit all the knowledge through that fabric.
I would say it's going to tie back to exploratory data analysis, right? Unless you actually understand the technologies that you're using to do the exploratory analysis, it's hard to interpret the results, right? So having some sort of, whether it be tool or process that makes the exploratory data analysis easier, and specifically the interpretation of the results, will go a long way.
No, great answers. And Todd, like how can industry help us? It's really about, while you're already ingrained within the DoD in the infrastructure, or you're looking to partner with DoD with your solutions, it's about democratization of that data. It's about allowing your solution to talk to this solution so that we can gain insight of what data is really going on. But not only that, but giving us lessons learned of what you've done with your solutions or your capabilities in other arenas, so that we can take that back within DISA and, maybe not do that, but kind of evolve. But that's how industry, that's how we can partner with industry, is, really getting after the tearing down of the silos whenever it comes to what data is really going where, but enabling it to really be crafted together, shared, viewed, analyzed for our cyber attack threateners.
And just to add a little bit more to that, right, one of the interesting things that you see is if I've got an environment that's run by a single vendor that's maybe covering all the tiers of the area, and they're allowing interchange of their sensors to provide IOCs back and forth. One of the problems we have in DoD is we don't have the same sensor in two places. And so providing that ability for my endpoint to talk to that boundary device to say, hey, here's something that I've identified, here's the IOCs, add it to your database as well, so that at all tiers they're now sharing that information. I'll put a plug in for some work that CISA's doing right now with something called Vulnerability Exchange Program, VEX. which I think is getting after that, to take the IOCs and be able to use those as part of the automation.
Yeah, good. Thank you.
Hi, Colin Patrick at DISA. So I used to be assigned to a cybersecurity service provider that had an MOA with all of their customers that all of the data that was collected by the sensors would be retained for data analytics. Have you looked at the ability for the other CSSPs to maybe develop those kinds of MOAs so that you could get vast amounts of data as part of that service offering without necessarily having to go to so many individual, I saw all the people on the DODIN chart, there's a lot of stuff there. Like, has that been explored? Because the amount of data that we would get, because it was part of the agreement with the CSSP, was massive.
Yep. So I'll put a plug in for it's called the Joint Cyber Warfighting Architecture, JICWA. And we put that in place years ago, and it was based on the concept that we've got this baseline platform and architecture that can share information back and forth. And the goal was that we have all the data flow into these big data platforms and then allow for things like distributed query, federated query amongst those systems. That was really the goal, so that the CSSPs from wherever you are knew your data was flowing in with their data, and then the correlation and things of that nature was getting after it. So that was the goal behind the JICWA structure that we put in place.
Hi, good morning. My name is Grace Gabriel. I'm with DISA BKI. So my question is, a major challenge in the utilization of machine learning algorithms is the concept of concept drift, where your current data model is becomes outdated as new protocols, new hardware comes in. And another area where that could possibly help with that situation is transfer learning, where current models are able to accommodate this new set of data to apply the existing learning to accommodate the new data to update the model. So this could be possibly related to the supply chain that you have alluded to, but in terms of how you're going to accommodate concept drift and transfer learning in the path that you had mentioned earlier. How do you want to accommodate these two concepts?
I think it's fun. So great point, right? The main thing is resources, right? So transfer learning can be valuable, like you said, because you don't have to go back and train a model from scratch. That can be expensive. You see this in open source landscape. You can transfer learn. Everybody knows GPT, so that's pretty common there. But with drift that you described, right, it kind of goes back to Robert's point. If we have labeled data or a mechanism to label that efficiently, we ultimately have fresh training data. So you can automate the process, the entire pipeline really, to retrain a model. And it doesn't have to be the same model. So you mentioned that model may have been outdated. So as resources become cheaper, neural nets, for example, emerged because compute was cheaper. So now a neural net may be a better solution than a random forest classifier, for example. But the thing is, right, you have to understand at a high level what the models are for. And you can set up some sort of process, right? And this is a valuable process to actually determine which model is best now, right? So that's programmatic, and you can validate a given model. And also ensemble learning, where you can take predictions from several different models and ultimately weight those. And you kind of get, I wouldn't say the best of everything, but you're weighting different types of models into a prediction. So the main thing to combating that drift is really just the retraining process. Now, is that based on model performance? Oftentimes, yes. You can set up a trigger that if model performance falls below a certain level, based on that fresh labeled data, we're going to retrain. Or it could be a job, right? Every day, every hour, every week, et cetera. So just a couple ways that you can combat that drift. But keep in mind, it's really always about resources at the end of the day. There's always a way.
Yeah, I want to interject. Great, Steve. Insight on this. I think to answer your question, your specific application, I think the best bet is actually prepare different model, as mentioned by Steve, and also actually the back end of it. You probably have another robots, right, for that purpose, and retraining that in such a way that they are easily accessible. That means you can easily find it somewhere. You just call a point. That means, that being said, that means you have multiple, right, models and multiple robots at the back already learn for certain things. For example, learning the network topology, learning some of the threats out there, learning some of the things that already coming in, and then you can call a point. That's exactly what happened to Google. If you take a look some of the information they have there, they have multiple, right, ChatGPT type of things that are already running and have different, interface to it, and actually different backends. That means it's not one for all, but many. Okay, and you can merge into one, or maybe call a point in certain occasion. For example, you talk about your case, right? Most likely, you'll have a certain robots or train a certain model already readily available, somewhere, in a pipeline. So you can imagine the pipeline have multiple robots already trained on different things. You can call a point.
Awesome. Question around when you guys do organic capability development for data science, generating your own models, do you guys rely on like CDAO capabilities and tooling, or do you essentially leverage best of breed open source? And then when you do that development and try to scale it from like a notebook to millions of models across endpoints, what are some lessons learned through that? Over.
Sorry, I couldn't quite hear the last part of the question.
Maybe just lessons learned from your experience taking like a single notebook, one model, and then scaling that across an enterprise to service the capability, like you were saying, for anomaly detection, threat detection, etc.
Rob, you want to take this one?
Sure, I'll start. We've found a couple of tools in industry right now that aren't made for making machine learning models or doing that, but really testing them. And so being able to take, either I built the machine learning model, or I've got a bunch of open source stuff that seems good, that I'll bring down and allow these engines to run through the algorithms. What I'll do is I'll provide sample data sets, and I'll provide, here's the output that I want, and these tools will do the analysis on it and come back and say, okay, this is probably the best model for you if you want it fast. This is probably the best model for you if you want it correct. So there's two different aspects to look at it for the output.
And I think at least, with us a lot in DISA, we partner with, our DoD CDAO partners, utilizing their Advanta platform, right? And there's a lot of great things in there that we're starting to use, starting to learn, and then taking that back to the DISA, enterprise and infrastructure, and then implementing that. But then we're also, partnering with our JAKE partners, since they're very focused on that AI, ML, and RPA evolution, for the DoD. So, we're really looking at getting our data, in a quality, a very mature manner, and then partnering with them, saying, hey, what should we be doing? Here's our model. Is it good? Is it accurate? And then bringing that back into the enterprise and looking at what that solution and what resources are needed to implement that into the infrastructure. Good. Okay. Cool. Last call. All right, with that, thank you guys so much for being part of this presentation.